Automating the deployment and management of infrastructure as code is a unique challenge, separate from other types of software development. Today, we are going to explore Spacelift, a Terraform cloud alternative that is purpose-built for automating IaC. Hey everybody, welcome to another Terraform Tuesday. I'm Ned Bellabance, nedinthecloud.com, and today's episode is sponsored by the good folks over at Spacelift. We'll start by talking about the challenges of automating IaC, then we'll look at Spacelift and how it can help you overcome those challenges. Then we'll do a demo of setting up a stack in Spacelift and show off some of the features. Finally, we'll talk about administrative stacks and automating Spacelift itself. But first, why is automating IaC such a challenge? Infrastructure as code is the practice of enshrining an infrastructure configuration in machine-readable language to enable consistent and repeatable deployments. At least, I think that's what the dictionary says. Tools like Terraform, CloudFormation, and Ansible all enable this basic functionality. But the real power of IaC comes from automating the deployment of that code. You could do all your IaC deployment and management by running manual commands from the terminal. But you've already taken the step of creating IaC, so why not go all the way and automate it with CI and CD processes? And it's more than just deploying a new version of infrastructure on a code push. When code is checked in, you can do things like validate and verify its correctness before deployment. You can stand up a temporary environment and verify the functionality of your code. You could run security scans against the code and ensure it meets your organization standards, or you can apply policy as code to make sure it doesn't violate any governance rules. These are all great ideas, but there are some challenges to the automation. Unlike application CI/CD, infrastructure as code is highly stateful and it seldom starts with a blank slate. While tools like Terraform and Pulumi are great at managing the state of your infrastructure, they don't provide a framework for automation and governance. And traditional CI/CD tools like Jenkins and CircleCI are great for application code, but they don't provide the same level of support for infrastructure as code. You can certainly use those tools, and I have. But you'll have to craft your own logic for dealing with common IaC operations, things like state management, cloud credentials, and execution plans. That's where solutions like Spacelift and Terraform Cloud come in. They fill in the gaps of open source offerings from Terraform and others, providing the necessary interface and workflow to manage infrastructure as code at scale. While this video is going to focus on Terraform, it is Terraform Tuesdays after all, I wanted to mention that Spacelift also supports CloudFormation, Pulumi, Ansible, and Kubernetes, and they've recently added native TerraGrunt support. I'm not the biggest fan of TerraGrunt, but I know it has its supporters out there, and if you're one of them, you can now use Spacelift to manage your TerraGrunt deployments as well. Now, you might be wondering, why would you pick Spacelift over Terraform Cloud? And that's a fair question. Both platforms provide a similar set of features, but there are some key differences that I'll try to point out as we review Spacelift and go through a demo. Spacelift is a purpose-built platform for managing infrastructure as code. It provides a framework for automating the deployment and management of IaC, and it's designed by DevOps folks for DevOps folks. It's from people who have real-world experience dealing with the challenges of managing infrastructure at scale. Spacelift is run as a SaaS platform and is built from a few fundamental concepts. The unit of deployment is a stack, which is linked back to a version control repository. Spacelift is assuming that your code is living in a VCS, and honestly, it really should be. Stacks are organized into spaces, which can be used to apply permissions and policies to a group of stacks. Spaces help you build a hierarchy and delegate control to different teams or group-like environments. In terms of the general workflow, since Spacelift is assuming your code lives in a VCS, it uses a GitOps-style workflow. Your stack is watching a specific branch in the repository for changes. A pull request or a commit against the branch will cause a workflow to run. You can also customize the workflow using push and trigger policies, so you're not locked into a single uniform workflow for all of your stacks. In terms of state data storage, Spacelift can store the state data for your infrastructure in a backend that is managed by Spacelift. You don't have to use Spacelift as the backend, but there are some benefits to having Spacelift manage the backend and the security of state data for you. Now, cloud providers that are included in your configuration are going to require some type of credentials to authenticate to their APIs. Spacelift has integration with the big three CSPs to manage those credentials for you. New temporary credentials are provisioned for each run, minimizing the potential for loss or replay attacks. Spacelift uses Open Policy Agent, OPA, and Rego to manage virtually everything on the platform, from access to control to workflow customization to checking for drift. Everything is policy as code. Now, I love this approach, and it comes in super handy if you're planning to manage Spacelift with Spacelift, something I'll touch on later. The pricing for Spacelift is very simple. There is a free tier for up to 2 users and 1 concurrent run. The paid tier is $250 a month for 5 users and 2 concurrent runs, and you can add additional users for $10 a user. Then there's an enterprise plan that you'll need to contact sales for, because there's always an enterprise plan and you have to contact sales. The good news is that costs are predictable and not based on resource consumption, number of stacks, or some other metric that is hard to predict and might impact your architecture choices. Quick note that these are the prices as of recording, and they may fluctuate in the future. That's enough talking though. Let's see Spacelift in action. For this demonstration, we're going to walk through a fairly standard Terraform deployment leveraging Spacelift. We'll start by creating a stack and associating it with a VCS repository on GitHub. Then we'll configure the stack with cloud credentials, variable values, and a policy to check. We'll trigger a run to provision our initial infrastructure. Then we'll make an update in code through a feature branch and walk through creating a pull request and viewing the proposed run in Spacelift. Finally, we'll merge the pull request and see how it triggers a new tracked run that automatically deploys if the plan and policies all pass. First, let's create a stack. In my browser, I have the Spacelift UI open. A stack is the basic building block of Spacelift, and it links back to a VCS repository with some code in it. From the stacks portion of the interface, I'll select Create Stack. On the name stack portion, I'll call this stack taco-menu, and I'll select a space that I already created called Taco Wagon. Spaces are a way of grouping together stacks and applying shared settings and policies to them. I'll leave the labels and description blank and move on to the Integrate VCS step. Now, since I signed up for Spacelift with my GitHub account, Spacelift already knows about my GitHub account and can read the list of repositories in it. I'll pick the Spacelift-Azure-example repository and leave the default of the main branch. If your code isn't in the root of the repository, you can specify a different project root here. If you're planning to follow along, you can always fork this repository and try things out for yourself. I've included a link down in the description to this repository. On Configure Backend, I'll accept the default of Terraform, which means that Spacelift is going to host the state data with the stack for me. In case you're wondering, it's actually S3 on the back end with some additional permissions and tooling around it. But the important thing is you don't have to manage it. I'll leave the default version of Terraform here, which seems to be the most recent release, and click on Continue. By default, Spacelift will use its pool of workers to run the stack jobs, but you can deploy your own pools of workers if you're on the enterprise tier. That is especially helpful if you're working with a secured network or a private data center. The administrative toggle is an interesting bit of functionality that I do want to touch on later. I'll expand the advanced options and toggle auto deploy. This will automatically confirm tracked runs that have a successful plan in place. I'll leave the rest of the options as default and click on Save Stack. Our Terraform configuration creates a resource group and a virtual network in Azure, which means Spacelift will need credentials to access Azure and configure the resources. I've already created a cloud integration with Azure, which creates an Azure AD application in my Azure AD tenant. Spacelift can use that application to create credentials on demand for each stack, which means no static credentials, and you know how I feel about static credentials. Going back to the stacks and into Taco menu, under Settings, I'll pick Integrations and select the Azure integration I created earlier. I'll pick the MAS integration and leave the default subscription. Now, if you're not using one of the big three CSPs, you can still use OIDC if you're on the cloud tier or higher. If you're on the free tier, you're going to have to use a static credential. For the permissions, I'll give it read and write so it will be used for both the planning and applying phases of the run, and then I'll click on Attach. On the Policies tab, there is a policy defined at the space level that automatically gets assigned to all stacks in the space. I can look at the contents of this policy down below, and I use an existing sample policy that looks for tags on resources. We're checking to make sure that all resources being created or updated have the environment tag set. If it's not set, there will be a warning in the run. The last thing we have to do is set values for the input variables in our configuration. Under the Environment tab, I'll click on Edit to create an entry. We've got two options for setting input variable values, either an environment variable or a mounted file. Since there's just one variable value to set called prefix, I'll go with an environment variable called tf_var_prefix. If I had one complaint about the stack onboarding process, I wish it auto-detected your input variables and suggested environment variables or a generic mounted file to use. Terraform Cloud and some of the other solutions do exactly that, and it's a nice time saver. And that does it for the stack. From the Taco menu stack, I'm going to trigger a run to deploy our infrastructure for the first time. It will walk you through the various stages of the run, including initializing and planning a Terraform run. And you'll note that I didn't have to craft this workflow, it's just built into Spacelift. Once the plan phase is over, the output will show two warnings and the run will halt, waiting for me to confirm. That's despite the fact that we have auto deploy enabled. If Spacelift encounters a warning during the plan, it will ask for confirmation before proceeding. I'll click on Confirm to deploy the infrastructure. This will move to the Apply phase and create the infrastructure defined in our configuration. Alright, and after a few moments, there we go, it's all done. But we should fix the code and push a new version to the repository to get rid of that warning. Since we're triggering on resource changes, we need to make a change to the code. So let's head over to GitHub and do that. In GitHub, I have the repository open, and I'll open the main.tf file and uncomment the common tag's local value to include the environment tag. Then I'll commit the changes to a feature branch, and from there, once I have my feature branch, I can open up a pull request. Over in the pull request, I'll add the title add environment tag, and then create the pull request. This pull request should kick off a run in Spacelift. Now, heading back to the stack, the proposed run is going to be under the PR section of the interface. Looking at the PR section, the run has finished successfully, and this time we can see that the policy check has passed without a warning because we've added in that environment tag. And if we go to the pull request over in GitHub, we can see all the checks have passed and what changes are being proposed to our infrastructure. So you don't have to go into Spacelift to check on the status of a run, it shows up in the pull request. I'm going to merge the pull request and head back to the stack to watch the tracked run. On the Runs tab, a new tracked run has kicked off with the details of the pull request merge that triggered it. And since we have auto deploy enabled, it will go directly from plan to apply because our policies are going to pass. After a few moments, there we go, the apply has completed successfully. If this were a production environment and we wanted to require approval before applying, we could have set that up in the stack configuration. The approval policies are also defined in Rego, and they're super flexible. So we could have required approval only for certain resource types, certain resource changes, or when resources will be destroyed. It's up to you to decide what needs an approval and what doesn't. You just saw how to create a stack in Spacelift, configure it with credentials and variable values, and kick off runs directly through GitHub. You saw how a policy can be auto-attached to a stack and evaluated during a run. We promoted a change through a feature branch and saw how Spacelift auto-deployed the change once our policies and plans passed. One other thing I wanted to mention is how you can automate Spacelift using Spacelift. It sounds weird, I know, but Spacelift has a robust Terraform provider that allows you to manage all aspects of the platform. You remember that administrative toggle in the stack settings? Changing a stack to be administrative gives it permissions to configure your Spacelift instance itself. You can use this to automate the creation of stacks, policies, and other settings in Spacelift. That's especially helpful with managing policy as code. You can have all your policies defined in repositories and apply them through an administrative stack, just like how you're managing your infrastructure as code. Now, I think this is an awesome integration, and I love that it's built into the platform. When you think about the challenges of automating your infrastructure as code, it's probably a good idea to pick a solution that was purpose-built for automating IaC, and Spacelift is an example of one of those. Spacelift manages key aspects for you, like access control to the different spaces and stacks, managing the Terraform state for you, and helping you manage your cloud credentials in a dynamic way, and you know that I like that. Another great thing that I really enjoy about Spacelift is the fact that policy as code is baked into the entire product. It's not just a feature that you apply to stacks, it's a way to manage all aspects of Spacelift, and they're using OPA to do it, and you know how I feel about OPA. It's pretty clear when you go through the Spacelift product that it was truly designed by DevOps folks for DevOps folks. These are people who have perspective and opinions on how things should be done, and I appreciate the way they do that. If you're interested in Spacelift and taking it for a test drive, I recommend going to spacelift.io and signing up for their generous free tier where you can do everything that you saw in this demonstration. Once again, the repository is down in the description. That's going to do it for today's Terraform Tuesday. Thank you so much for watching, and thank you to Spacelift for sponsoring this episode. Until next time, stay healthy, stay safe out there. Bye for now.